Hi folks, this video is going to look at change and what we do with that mathematically. So let's jump right into it. So first of all, for amounts of change, the amount of change is defined as the final value minus the initial value. And this should be pretty intuitive, I think, from your daily experience. If you were 10 years old and now you're 20, you take 20 minus 10 to get the change. The way that we would write this symbolically is delta x is equal to x minus x naught or x0. So this right here is delta. That's what we say, that's the Greek letter, and this means change in whatever comes after. The x is x, straightforward, and this right here is naught or 0. So you can say x minus x0, you can say x minus x naught. The naught is kind of more of a Britishism, but it's something I picked up from the university, so it sticks with me. And then this is obviously the changed value, this is the final value, this is the initial value. And one thing to note, the delta doesn't mean anything on its own. It always must be connected to some variable that comes after it. So now that we've discussed change, we can talk about the rate of that change. And so the rate of the change is how much one thing changes compared to another. And so we always have to have, when we're talking about rates, we always have to have respect with respect to. So for example, we might say the position is changing with respect to time. That would be the rate of change of position with respect to time. F of x changes with respect to x. As x changes, the f of x is going to change. And then say you've got an example of a pool of water, the rate of change of temperature with respect to depth. So if it gets colder or warmer as you go up or down, then you can say that as I change my depth, my temperature will also change. So these are all examples of rates of change. And again, it's key that we have this with respect to when we're talking about rates of change. If we want to calculate the average rate of change, this is nice and straightforward. It's just what we've been doing kind of for a long time with averages. So it will be the change, there's three forms of it, 1, 2, and 3. And kind of the straightforward general form of it would be just writing delta f of x divided by delta x. So the rate of change of f of x, or the amount of change of f of x divided by the amount of change in x. If we want to expand this out, this can also be rewritten as f of x minus some other f of x divided by x minus some initial x. And then finally, we can write it with respect to this delta x, where this delta x just means a small interval of x. So there's three ways to look at it. 1, just the change in the function divided by the change in x. 2, writing that out as a position minus an earlier position on the bottom, and then on the top, the function minus the function at that position earlier. And then 3, kind of having some baseline initial position, but then adding some small interval to the x and seeing what your change is. These two are related because in the numerator or the denominator of this one, it's actually kind of like saying x plus delta x as one position minus that initial position, and so you can see that these x's cancel out, and that's why we're left with just the delta x. All three of these are the same thing, they're just different ways of writing it, and they're all called a difference quotient. So if you see, write a difference quotient, blah, 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 this is what they're asking for. So that's the average rate of change. Next, we're going to talk about the instantaneous rate of change. And this is just taking the average rate of change and making that interval smaller and smaller and smaller and smaller. So as delta x gets smaller and smaller, this term, f of x plus delta x, and this term, f of x, get closer and closer together, and this becomes a smaller and smaller interval. And so you can imagine if we have, say, a function like this, and I want to estimate the rate of change right here. Well, if I start by taking this point and this point over here, we can see that that gives me an estimate that, is pretty close to what we have. But if I come in closer, my estimate gets more and more accurate as I get, closer and closer to this. I get a line that's closer and closer to this tangent line. Another way of writing this would be the limit as x approaches a of f of a minus f of x divided by a minus x. And these are just kind of riffing off or taking the second and third form of the average rate of change and then making their intervals smaller and smaller until we approach 0. So that's what we're looking at when we're talking about changes and rates of change.